Again, thank everybody for coming out today to attend the webinar. Our agenda for the webinar today, do a quick introduction about me. We'll look at the March 2024 release highlights, the May 2024 release highlights, which actually just came out this past Tuesday evening, some special notes, and then a Q&A session as well. Just a bit about me. I am a solutions consultant here at IMAGINiT. Prior to IMAGINiT, I worked at Autodesk on the technical marketing team for Fusion. And then prior to that, I was a consultant to Autodesk, had a residency at Pier 9, was an expert elite, certified inventor professional, so on and so forth. Been in the Autodesk ecosystem for quite a long time. So let's jump into the meat and potatoes here of our release information. We'll start with March 2024. If you look at the What's New blog for Fusion, you'll see that there's actually several minor updates that have occurred throughout March and into April. But this is just going to look at the top level, the original release for March, and some of the features that are in there. Again, these are highlights. We're not going to hit every single thing. But we are going to take a look in detail at a few things so that you can kind of see the new functionality that has been brought into Fusion. So as a brief overview, there were changes to nearly every single workspace in Fusion in the March release. They include numerous performance and stability enhancements, lots of bug fixes as usual, and a brand new project management experience that includes some new roles and new permission settings as well. So we're going to break this down into sort of workspace areas or process areas. So to start with, we'll look at project and data management for this March release. So the first thing that we want to talk about is BOMs. BOMs have officially been released in Fusion. This has been something the community has been asking for years and years, and it's finally here. Hooray. You can see a picture of a BOM there on the right-hand side, and we'll actually look at one in detail here shortly. Additionally, for project and data management, we have new user roles, groups, and permissions. This allows much more granular control over who has access to what in your files, and that includes non-CAD access. So if you've got administrative folks or quality, metallurgy, things like that, that just need to review CAD data but don't need to actually create CAD data, there are now a lot of new roles and permissions that can help you establish communication with those teams using Fusion. The last thing we'll hit as a high point on project and data management is that configurations that have external references in them can now be used with the Manage extension as well. Previous to this, they actually weren't able to see those configurations that had the external references. So let's take a quick tour of this new bill of material functionality that's in Fusion. We'll look here. This is an IoT device, a solar power repeater, transmitting some sort of data out in the field. And we can see here it's got quite a few components into it. And we want to be able to track all of these components and their relationships with each other. And so we now have the BOM functionality. It lives here under the Assemble menu. We can go to Bill of Materials. And here we see the BOM functionality in Fusion today. Across the top here, just to show, there's a chain link here. It's a hyperlink. It copies this link and spits you out in a web view of this. So if you needed to send this BOM to someone just to view it, you can use that link. There's also a download functionality. So that's going to download either Excel files or CSV files. And then we can change which columns we can see. And if you're using Fusion Manage or the Manage extension, there is some additional fields that can be shown here as well. We can see here, if we go into each of the sub-assemblies, we can see all of the individual components. You do get a thumbnail for everything as well. We can see whether it's an external XREF or an internal one, and if it's a milestone release or not. We'll look at another example here. So this is an oldie but a goodie, the Autodesk Ember 3D printer. We go up to our assemble block here, go down to bill of materials, it pops back up again. And again, we can come in and see all of the sub-assemblies and individual components that are now inside here in this BOM view. Now, I went ahead and pre-downloaded this. When you do the download to Excel, it does take about, I don't know, 20, 30 seconds or so. But to show you what the output looks like, this is that raw output of the Excel file. So we end up with a level. So this tells us where these files are located in this sort of nested formatting here. Part number, part name, is it external or internal? Is it a milestone release? And so on and so forth with the metadata that you would expect to see here. So this is the first time in Fusion's history that we now have a native BOM tool that's able to understand the CAD file and interpret what the relationships are between the different components. Moving on to the design workspace for the March release. There's a few things here of note. One is the skip view transitions. If you're using the view cube or named views, when you pick on one of the faces of the cube or you initiate one of your named views, the default behavior is to rotate the part around. You get an animation as the part moves in that lowest energy rotation to get there. There's now a setting though that we can turn that off. And so that's the skip view transitions. Next up, we have some enhancements to configurations. We can now move rows and columns inside the configuration table. And lastly, something of note here is the fastener library has had some major enhancements, including the replace fastener functionality and the inclusion of favorites now. So if you use a consistent set of fasteners, you can add them to your favorites list and keep them on tap. This is really handy because the fastener library is growing quite quickly. There's so many different fasteners in it, it's almost hard to navigate. So favorites makes it really nice if you know you're going to be using a consistent set of fasteners. Speaking of fasteners, let's go take a look in Fusion at how the fasteners tool works, just briefly, and some of this new functionality such as replace fastener. So we'll go back to our IoT device here. It's actually got a few different fastener sets on it. This is a solar panel here that's attached to a sheet metal bracket. And using the fastener tool, these actually live down here in our timeline. Now you'll notice that there's a grouping here for the washers, a grouping for the actual fastener. There's a washer on the backside and then a nut as well. So if we wanted to change this particular fastener here, we can right click right down here in the timeline. And now there's a function called replace fastener. When we start this replace command, you'll see that this now allows us to change the size, the material, the finish that's on it, any of this associated data. We can also do things like change the length. So if we need to change to a longer or shorter fastener, we can do that as well. All right. The beauty of these fasteners that are now live, they've been live since, I guess, October of last year, but they're really coming into their own now. They don't require you to save the fasteners as XREFs of any kind. It works a lot like the Content Center does in Inventor. So there's no need to store a whole bunch of extra files as you use them. It just generates the geometry on the fly. They do live in the fastener folder here in your browser. If we open that up, you can see all of those. And they are considered XREFs, but they live in a different place. So you don't really get access to those to edit them individually. This is nice though, because if there were to be a change to that fastener, Autodesk is taking care of that and not you. Up next for the March release, we go to our drawings workspace. For the drawings workspace, there's a few things to talk about here. First off is perspective views. So this is new for Fusion to be able to have those views that have the vanishing point. The functionality at the moment has two different focal lengths. So one is a pretty normal as you experience it with your own two eyes in stereoscopic vision, and one has a very short focal distance that creates those very exaggerated, tapered views. So those come in handy for artistic renderings, for patent documentation, things like that. Next up, we've got curve, min, and max snap point, and that's actually what you see in this GIF here on the side. So what's happening here is we're using that curve geometry to grab the top and the side of that boss by using the maximum point on it. So you might think of this in terms of maybe AutoCAD as quadrant, if you were familiar with that. In this case, though, it's just grabbing those as the maximum or minimum extents of that curvature. The last thing to mention is section view performance has been dramatically enhanced. You'll see different hatching and line weights have been applied that make it a little more clear to understand, and it's much faster. Simulation and generative design. There's quite a bit that's happened in here as well. First thing is starting shape option. So this is an option in generative design to sort of auto build a starting shape from an existing design, as opposed to manually drawing or manually modeling up geometry that touches all of your preserves and avoids all your obstacles and this, that, and the other. If you're using an existing design, you can use that as the starting shape now. Next, we've got improved casting constraints, and that's what we see on the screen here, the before and after. So these new casting constraints create better geometry. It obeys the rules a little better as well, as far as minimum section size, minimum feature size, and draft is obeyed quite a bit better as well. And generally, you can see it also produces a much smoother result than it used to. We have view synchronization in injection molding and electronics cooling. So this is where you might have multiple studies that you're comparing side by side. There's been a major material database update for injection molding, and there are improved error messages for quasi-static simulations. Next up, we see the manufacturing workspace. So there was a lot in here. I just picked these three as some pretty good high levels. The first thing is that threading turning tool inserts now have enhanced parameters, and you can see here that that's what we see on screen. There's quite a bit more information than there used to be. It still doesn't cover every insert potential, but it covers most of them. So this is a welcome change to get new parameters for these. This includes things like flat nose instead of pointed, so on and so forth. Different kinds of geometry that you come across in everyday use, but wasn't available prior to now. In addition, we also have additive arrange component priority. So this helps us to stack our build volume according to which components are more important or which components need to fill the space better. And lastly, we have flip directions for multiple open chains. So this is in reference to milling, for example, if you've got an open contour that you're following, if you've got multiple open contours and you need to change the directions on them, now you can do that individually all at the same time, as opposed to having to create new operations for each one of those discrete open chains. All right, so that was the March release. So that's been around for about 6 weeks now. So now let's look at May, which was just released on Tuesday evening. You may not even notice the changes in Fusion yet. So let's talk about some of the things that are here. So this is our overview. There are some big additions to the design and manufacturing workspaces. Again, there's numerous performance and stability enhancements. There always are. And two things in the design space that I just love talking about are solid sweep and enhanced shell. Solid sweep is where we get to drag a solid body along a path to create that swept volume. And then the enhanced shell provides a curved offset or a straight offset. Straight offset is what the old functionality was. The curved offset allows for partial shelling so that you can continue to work on it in the surface environment if you need to for more complicated shell operations. So we start again with data management and usability. The first thing you might notice is there's a new splash screen for Fusion. And at the bottom of this splash screen includes a new status bar that tells you what's loading. This is useful in case you get a hang so that you can watch this and see what component is not behaving correctly and see if you can do something about it. It might be an add-in that's acting up. It might be a script that's acting up, or you might need to run the repair tools to reinstall or repair your installation as well. Next, JT files can now be uploaded from the data panel. There's one caveat here: they have to be the monolithic version. The structured versions are coming, but for now, only the monolithic. And then lastly, physical materials can now be seen both on the web and in the Home tab for milestone release designs. So that's what we see on the right here. So this is looking at like the web view or the home view. We can see that on that components list there. Now we can see the material, the mass, the volume, the density, area, so on and so forth. All right, so in the design workspace, we've got four things to talk about here. First one being solid sweep. So I mentioned this one before. This is where we take a solid body and sweep it along a path. This functionality has been in Inventor for a few years now, but this is the first time it's been in Fusion. I use this frequently in my generative design work, and we'll actually look at an example of how that comes into play momentarily. The rounded shell that I mentioned earlier. So this allows us to partially shell complex objects, or to get a more, not necessarily organic, but at least a curvier surface inside when we do shell operations. There is now a dedicated insert component command. Previously, you had to open up your data panel if you wanted to bring in an XREF and either right-click on the item in the data panel and say insert into current design, or click and drag. Now there's an insert component command that lives in the insert menu on the ribbon. And lastly here, multi-hole patch. So previously, a patch in Fusion could only be on one hole, one opening. So in the case of the flange that we see here on the screen, if we wanted to patch all of those holes, it would be a large amount of individual patch operations. And now it could all be done in one operation in the timeline. So let's take a look at solid sweep. So here I have a toggle clamp, like you might find in manufacturing setting. And what I would like to do is, for the purpose of whether it's machining or maybe generative design, figure out what the total volume of this thing is as it moves through its range of motion. So the very first thing that we would do is we would just specify what's the path that all of these pieces are going to move on. So I'll quickly create a midplane here. Actually, we don't need to create a midplane. It's good to go right there. We'll use that plane. Turn on our origin so we can see it. We'll drop a sketch here. I'll just do some quick projections. So this is the primary axis of rotation for this whole arm as it moves back and forth. I'm also just going to grab this face of our little rubber plunger here. So I'm going to create some reference geometry. So I'm going to make an assumption here that this swings up 90 degrees. So I've made this perpendicular. And these two legs are equal length. Now I put a circle here. So this is the arc that this arm travels. And if we trim this up, we can kind of see this better. I'll make these construction so that they don't get in our way. So now we have just this arc through here that this component, or all of these components, travel as they move about. So we go to create, sweep, and in the sweep type at the bottom here of this list, we see solid sweep. So solid sweep allows us to pick a body and then the path. So we would start with, say, the rubber plunger. Our path would be that we created. Let's see. Why didn't it like it? Let's try it again. Sweep, solid sweep. There we go. So there is the solid volume of this stopper as it is swept through here. I'll leave this as new body for the moment. And we can continue to do this. So if I bring my sketch back out, we can do it again. We could sweep, say, this arm here as it goes along that same sketch path. And if we don't necessarily want to go the entire distance one direction or the other, we have all the controls that we could move it about. So in this case, I might say it doesn't go any further than that bottom edge there. So we'll go 0 in this direction, and then the full distance 1 in the other direction. So that continues to give me more solid swept volume information about the travel path of this arm. So we could continue to do this to build this out, and then maybe combine all those bodies together in order to create the obstacle volume of our entire toggle clamp. So this becomes really interesting when you think about maybe a robot arm. When you're trying to figure out what's the occlusion zone around a robot arm, you can use the solid sweep to drag the end effector through space to figure out what that volume looks like. In terms of generative design, this becomes really nice for obstacle avoidance. You can do things like drag a tool through an access path to get to a fastener, or something like this toggle clamp even. You could also think about maybe pedals on a bicycle, or the legs of the rider as they pedal the bike. Things like that. So that's where solid sweep is really going to come in handy. Next up, let's look at the multi-hole patch. We'll hop back over here for just a moment. So this one's a very simplistic model. We'll do a simple one first, and then we'll do a much more complex one. In this case, we've got some sort of housing for a water meter here. And we can see the new patch tool allows us to specify these faces all in one go. So if we were trying to send this out to CFD, or maybe we wanted to create that fluid volume or boundary fill of our surfaces and then the solid itself. Of course, I picked the wrong one there. But that allows us to get all of the information that we want in order to create that filled volume here. So I'll pick this one this time. Hey, there we go. So now we've got our fluid volume. A little more complex of an example here. So this is like a rotary engine model. And this has a water jacket that goes around part of it. And it's got the intake and exhaust and spark areas as well. So just to show how fast this goes, we can use our patch tool and rapidly come through and grab the different areas of the model that need to be patched up. So we've got one here, here, we can't forget our big ones there. And I think we got them all. All the rest of these are just bolt holes. They're not part of anything different. So we were able to create all of these surface bodies using that patch tool in one go. So you can see in our timeline, there's only one patch operation. There's not however many of these, 10 or 11 individual patch operations. So that then we could come and do, again, our boundary fill. And get whichever cells we were interested in. All right, moving on to the drawing workspace for the May release. Three things I've mentioned to mention here. The first is match dimension. So match dimension is an interesting one. If you have a dimension on your print that has a different set of tolerances than everyone else, and you want to copy that particular set of tolerances elsewhere, you can use the match dimension tool. This is a lot like the format painter from Microsoft Office. So essentially you pick a dimension that you want to propagate its properties to other places, and you use the match dimension tool to drive it other places. Next up, taper and slope notes. So there's a new leader associated with taper and slope notes. It makes it a little easier to figure out what you're grabbing. There's no need for any helper geometry anymore or anything like that. And then ISO section lines are now correct to the ISO spec. All right, manufacturing workspace for May. So the first thing to talk about is part positioning with machine preview. What this means is when we do a setup for our machining, in the setup dialog box, there's now a new tab that allows us to investigate the part being on the machine and how it is oriented. So this helps with setting your XYZ axes, your touch-off points, so on and so forth. Next up, we have bar pull. So there's a new strategy to do bar pull in the turning tools. So this is where your subspindle is going to come grab the part or grab the raw stock and pull it out of the chuck. So it's going to do a subspindle return and then let go. So this is a nice way to do sort of cheater version of bar feeding by pulling with your subspindle. Next, we've got first path depth for turning threading. So if you've got exceptionally hard material and you want to take a very light first pass to get a groove going and then take your deeper cuts later, you can do that now. So you're not having to break that into two different operations. It can be all in one. We also have face mode for turning. That's actually what the graphic is on screen. So there's a better, more intuitive way to do face turning now. And lastly, in the additive world, we now have fill the build space with quantity limits. So if you're trying to maximize your output of your powder printer, for example, you can say, fill it up with such and such part. Doesn't really matter what the context is there, but you can say, I only need X number, so maybe 30 of some part, and then fill in with the rest. So this helps to optimize in a production style environment to make sure you get the right throughput out of the machine without creating extra parts for no reason. All right, so let's take a tour of part positioning. So we are still here with our rotary engine model. We'll just turn off these surfaces for the moment. And let's go to our manufacturing space. Now, I've already got a setup here, but we'll go back and look at it. So in our setup creation dialog box here, there's this new tab that says part position. And when you go to the part position tab, it actually brings the machine model in, assuming that you have specified a machine here on the first tab there. It actually brings up the machine model to allow you to see how you are orienting the part in the machine. And we also have the ability to specify, or not specify, but preview the motion of the machine as well. So when we click this preview machine setting here, it brings up the machine jog. And so we can see what the machine's going to do with the part. So here we can see our Y motion, our X motion, our trunnion A, cable C, and Z is capable as well. So this helps you to visualize how you have the part oriented. Does it make sense to you? Does it make sense on the machine? A lot of times this is super helpful for if your X's and Y's may be inverted, maybe they're backwards to each other, or maybe you inadvertently picked the wrong stock point on your stock, your touch off point, your 0, 0, 0, if you will. This will help you to see that so that you know where to put everything. Lastly, if you've got a trunnion like this, it's going to help you make sure that your part is centered the way that you want it to be, so that you can look at this rotation and see if that's correct for you or not. Now, obviously, I don't have any vise or work holding here. This was just a quick demo, but that's would allow you to see if everything is centered correctly or not. And we can rehome everything with just the quick click of a button. All right, so there are a few special notes worth mentioning for both of these releases that I just wanted to throw out there. Special notes, the first one being that with the March release, Big Sur, macOS Big Sur, is no longer supported. So it's just something good to know. Number two, the Manufacturing Sustainability Insights tool has been released. So this is a tool that Autodesk has put out. It's available in the Autodesk App Store for Fusion that will tell you roughly what the CO2 expenditure is going to be in order to create your part. And I actually have it installed. We can take a quick look here. So if we look at, go back to our water meter here. We'll hide all this stuff. So in our water meter, if I go to my utilities here and add-ins, it's actually already loaded. This is the icon here, but it lives in the add-ins. It's called the Manufacturing Sustainability Insights. And when we pick this, what it does is it asks us to look at a body and determine what kind of manufacturing we're going to be doing to create this. So I'll say additive, which in this case would be something like casting. It doesn't have to be 3D printing, but we'll do like casting in a material, and we can choose one of these close materials if we don't have one that's specified correctly already, and then where we're going to manufacture this. So if I was going to manufacture in North America, we can see here that I get a rough CO2 equivalency of 78 to 107 kilograms. We can compare that process. So in this case, it's actually looking at binder jetting, directed energy deposition, or laser powder bed fusion. So in this case, these are all three true 3D printing processes, so casting was not considered. If we had chosen subtractive here, we'll get different results. And again, this is going to look at this in terms of different ways to create this. Now, this doesn't look at the part in terms of actual manufacturability. It's just looking at it in terms of the amount of material that's involved and the amount of removal of material to get to the end goal as well. So we can see just the basic calculations. Again, here's like the billet mass, and it tells us what the assumptions are that it went with as well. So that's the manufacturing sustainability insights tool. Next up, Upchain. Upchain has been renamed and absorbed into Fusion Manage. So if you were looking for information on Upchain, it's now part of Fusion Manage. That change has happened within the last month. Similarly, ProdSmart, within the last month or so, has been renamed Fusion Production. So these are just some branding changes, those two, that are worth knowing about. And then the last thing I thought I'd mention is Project Salvador, which is a generative AI built into Fusion. It's kind of interesting. It's just a way to ideate a little bit. I can show you here. We'll just toss open a new design. So when you install it, you actually run it here, and it says, you know, what's the prompt here? And so we could say rugged IoT device with antennas and solar panels. Now, what's interesting is if I generate from just that prompt, it will spit something out, and it probably won't be great. We'll let this cook for just a moment here. It doesn't take very long at all to get a result. But because I put in what I thought it should get, and it was probably a little too simplistic, what I get out the other side may be a little bit crazy. So we can see here, this has spit out this image here. And you know what? Okay, interesting, but clearly weird, right? So there's this option here that says enhance prompt. And what's really interesting about this is it reads what your original prompt was and tries to make it better. And so it adds new wording. It also adds new criteria. And you can change this. You could come in and type in here if you wanted to. But this kind of attempts to add more granularity so that you get a better result out the other side. And again, I just generated off of that optimized prompt. We'll see what it comes up with. Little more realistic, I guess. Maybe not perfect, but it feels more realistic than the first one. We'll say that. Now, there is an option to review your previous results, so you can kind of get a feel for how you've gone through and looked at things. You can see I tried a couple of other things earlier. This was that same IoT prompt from before, and this was a sketch version. So in addition to creating just these as generic images, we can also do a sketch creation. And what we mean by sketch creation is it tries to generate a vector drawing with limited colors. And so if we specify that as sketch creation, you'll see as this generates the new prompt here, it'll take what I wrote and then include things like high contrast, 2.5D rendering, so on and so forth, in an attempt to give you a more sketchable or easier to ideate from image than some of those photorealistic rendering styles. We'll wait just a moment for this one to finish up, and then we'll move on to our Q&A. There we go. So you can see here, much flatter image. It's still in an isometric view, but the color palette is much more subdued, and it's not quite as weird airbrush AI that we're all kind of used to these days. So that's Project Salvador. I encourage everyone to go tinker with it and see what ideations the machine can do for you.